how are you guys feeling? I mean, this is a wonderful outcome. We were expecting some of you just to sleep in and, just not come at all, but the place is packed. So round of applause for yourself for coming and waking up early. Yeah, that's for all of you guys here. Exactly. Our next speaker, his favorite movie, I don't know if you know this one, it's Back to the Future. That's his favorite movie. Also, his last name, his last name is the half Italian currency, the same as half dollar. So you can call him the Italian 50 cents. Also, as he's from Italy, so he pays attention to his looks. And he told me he spent tons and fortunes on his haircut. You can see that, right? So without further ado, how you're doing?
In a moment, I should be all right.
He should be all right. He's still all right. So once again, after his speech, you have 15 minutes. So just relax and remember, drink some coffee, get pumped. So without further ado, Luca Mezzalira.
Thanks, mate. Hello. Thank you very much. Okay, so after this talk about asynchronous programming, let's go ahead with that, right? So let's talk about something that I really like, that is functional reactive programming. I will talk in particular about Cycle.js. And that's what basically I did in the past 2 years. So my name is Luca. I'm solution architect in DAZN. DAZN is a service very similar to Netflix, but instead of broadcasting movie, we are broadcasting sport. We have an office also here in Poland, in Katowice. So if you're interested about that, please ping me later on. I'm a Google developer expert on web technologies, and I'm the manager of the London JavaScript Community. So if you are in London and you don't know what to do, usually we have a meetup there. So today we are going to talk about a few things. We are talking about, first of all, reactive programming, because I know that maybe a few of you don't know what reactive programming is. We are talking about, for me, an interesting part, that is the reactive dictionary. So what does it mean, reactive programming, what is a stream, stuff like that. And last but not least, we will see a real implementation. We talk about Cycle.js, that is a functional reactive framework. And last but not least, we see a fully implementation of a reactive architecture. That is what I love it about Cycle.js. So let's start with reactive programming. So as you know, reactive programming is a programming paradigm. There are many of them outside there. We got imperative programming, we got functional programming, we have reactive programming. So let's take a look briefly about imperative programming. So imperative programming usually is the one that you are getting used to write at the beginning as a developer, where you describe exactly what you're doing step by step. Think about a for cycle, where you are defining who is the name of the variable, which is the name of the variable that you want to increase, which is the condition that you want to meet, what's happening inside the for cycle. And then we move to another programming paradigm that usually is not, it's the opposite of imperative programming. It's functional programming, where we use function and we try to create, let's say, what is called pure function. So basically a function that will allow us to have always the same output without creating any side effect on our application. Every time that we use the same argument. So I have the same argument, I always have the same output. Otherwise, it's not a pure function. The other cool thing is, in functional programming, you focus more on what you have to achieve. So what the program should do, and more than how to write that. And then suddenly we have also reactive programming. So what the hell is it? Reactive programming is, it could be used in both. You can use an OOP reactive programming style. You can use a functional reactive programming style. And the interesting part is basically is introducing the concept of time inside your application. And if you think about that in particular on front end, where usually the front end you are listening for something. You are awaiting that you're waiting that your user perform an interaction inside your program, or you receive some data from a server. So it makes a lot of sense on that side. So in order to explain a little bit about reactive programming, the first thing, and for me the most important thing about that, is understanding this part here, the difference between interactive and reactive. So interactive programming is, let's think about two objects, object A and object B. So usually in interactive programming, A owns or create or is injected B, and start to interact with it. Like, for instance, I got inside my object A, the object B, and I call a method for him, or retrieve a property from it. In reactive programming, it's completely different. So in reactive programming, you don't care about B. So B will be notified that something happened, and we react to that change. And that's the key thing. That it looks very, very small change, but it's a completely different paradigm if you think about that. So let's see an example. This is a very, very simple example. So we have like a class calculator and a class receipt, okay? Basic stuff. What we do is the calculator has just a method that is exposed as sum that return, let's say a sum of two values. And then the receipt instead has to display the total of receipt. Nothing else, nothing more. So what we have here is that at this level here, we are injecting the object we created here, that is the calculator, inside the receipt. And inside the receipt, what we're doing is interacting with that. So as you can see here, we have this.calc.sum. So I know how to use this specific object. I know that there is a method available that is called sum. That's the interactive approach. And this is the vast majority of the time, I saw code like this with my developers. But let's see a reactive approach to that. What if we introduce something else? So what if calculator, in this case, doesn't know anything, receipt doesn't know anything about calculator? What if, in this case, we don't use directly a calculator, but we use something that is a contract between the two objects, that is a standard contract? And in this case, it's an observable. We will see in a moment what an observable is. But let's think that we have a third object that is injecting inside my receipt. And in that case, what is happening here is this. So I'm just subscribing to it. Okay, so I'm subscribing to this third object, and I'm waiting since when something happened. So when I receive some values that are obviously I perform at this level here, I do stuff. Okay, so pretty simple, but it's completely changing the paradigm, because now when we got this, it means that I can decouple totally calculator receipt. The refactor for me is way easier. Also, the way how I'm going to test these classes will become way easier. And if I want to change the receipt, swap the receipt with another class or object, I can do that. It's not a problem. I'm not going to affect anything inside my program. So usually, every time that I speak about reactive programming, the first thing, and I saw a lot of, I read a lot of books, I read a lot of blog posts and stuff. One of the things that I think that is the most difficult part to approach is the dictionary. So reactive programming has a completely set of words that you need to learn in order to understand how it works. And that's something that often people, they don't pay attention, they just take the first library, I don't know, most.js or X.js, and they start to work with it. But you need to understand what there is behind, because otherwise you just work with the top of the iceberg. But the iceberg is way bigger than that. So let's. I have just a few concepts for you today, just to explain. So this is the main one in reactive programming, the streams concept. So a stream is a sequence of events that are ordered in time. So when you start to work with reactive programming, you get used to watch this kind of diagrams. This diagram is called marble diagram, and basically is describing what a stream is. So the horizontal line that you can see here is a timeline. Okay. So I know that in a certain point on my program, I received the value 1. Then I received the value 2, and then again a value 3. Potentially, this value could be generated by a user interaction. It could be generated by, I don't know, the data that are retrieved from the server. It could be generated from anything. Because as you can understand here, the concept is pretty simple. So I'm passing these values inside in a certain amount of time inside an object. It could be applied to anything. You can replace listener. You can, I don't know, replace that in retrieving HTTP request results, and so on. So this concept here, it could be applied anywhere. And that's why in reactive programming we say that everything can be a stream. Another thing to remember about this diagram is the last part here. So this vertical line, it means that the stream is completed at that moment. So each stream can usually have like receive a value. It could generate an error, it could receive an error, or it could receive a complete signal. These are the three things that you have to remember. A special type of stream is the observable. And that's the observable, the key part of this. So there are several libraries that currently are available in the reactive panorama. We got, I don't know, React.js, we got Xstream, we got Most.js, we got really, really many of them. And every day there is a new library that is coming over. The interesting part of this is that the observable, if you are familiar with observer pattern, maybe reminds the name a little bit. On top of it, there is also the iterator concept. So an observable is composed by two patterns, the observer pattern and the iterator pattern. In the observer pattern, what we do is basically create a subject, what's called concrete subject, and usually there are some observer that are listening, so they are subscribing to that observer, so that subject, and then every time that the subject is saying, okay, something changed, it is notifying all the observer to that. And it's exactly the same thing here. So I create a range in the first line of 5 numbers that is inside an observable. So I have these values that are ready to be pushed to an observer. So to be emitted, sorry, to an observer. And then I create an observer, and what I'm doing is just saying, okay, so every time that I receive a value, remember always the timeline in this stage that I showed you before. You can have like the first thing in when you create an observer is the method that you receive the value. So it's and that's why there is console log here. Then you can handle the error if you want. It's not mandatory, but it's very. I suggest you to do that. And then the last thing is what happens when the observer, the stream is finished, is completed. And when I do that, I start to receive this value when I do subscribe. So when I call the subscribe method. So nothing else. It's not magic. The nice thing of this is that, yes, now you can see a basic implementation, but what if I can say you all the things that you have just saw with Tomasz could be evolved in a way that with these libraries that they're providing a lot of utilities like operators that will allow you to multicast this information to multiple objects, or you can reduce map, or you can retry a specific action. So it's literally, you can do whatever you want. These are the two key concepts that you have to remember in reactive programming. When you understand what an observable is, what an observer is, then you can move to the next step. Next step would be, I don't know, understanding what is the back pressure, understanding what is a hot and cold observable, but you can start easy, okay? So today we're going to start easy, and we will talk about Cycle.js that is using Xstream, that is one of the library that I mentioned for reactive programming, and Xstream was created by André Statz mainly for teaching how reactive programming works. So let's talk about Cycle.js. What it is. So it's a framework that is it's pretty basic. There isn't rocket science. I think the first implementation of Cycle.js was around 100 lines of code, so not much. Okay, very light. The interesting part is leveraging this concept here. So his creator, that is André Statz, basically started to think and work on how the things are working in the real world. So it's try to create this connection computer-human, and basically is how it creates a cycle. So cycle, as a name, is a feedback loop that is happening between input and output from the external world to the internal world. And as the internal world, I mean our program. So here, as you can see, you have different input and output. In the case of the human, the input is the high in this case, and the output is when I interact with something like my mouse. In the case of the computer, the input is the user interaction, and the output is what I display on the screen. So if you think about that, at the end of the day, what we got in Cycle.js is exactly this concept. So what we are trying to achieve is creating some small cycles that are predictable, and I know what basically I'm going to display. And that's the main concept about that. So as you can see here, what we got here is just two different containers. One is in order to create side effect, that is this container at the bottom here. And the other one is our program. So basically the concept is every time that you have to interact with the external world, you try to create this kind of side effect here. Instead, when you want to do something inside your application, you can have a source as input. You operate on different things inside your application, and then you output something that is then managed by the external world. If you think about that, it's a pretty interesting concept because no one is preventing us to create multiple of these applications. So potentially, with Cycle.js, you can create what is called a fractal architecture. A fractal architecture is a very powerful concept because it means we can replicate exactly the same architecture in any scale on the client in a way that it fits the components, and the entire application will look like exactly the same architecture, but it is composed by multiple of them. So potentially I can wrap my Cycle application inside the larger Cycle application and use the first application as just a component of the main one. And that's the powerful of this. Often this is ignored because we are getting used to just take a framework or whatever and immediately start to work on it. But if you stop for a moment and start to understand what there is behind it, this is potentially quite disruptive because you can literally enhance your application and add new features in no time without much work to do on the synchronization and everything. So there are a few core concepts inside Cycle.js, not many. So we got the concept of pure function. We mentioned before what they are. We got the concept of stream, and we saw before what it is. And now we got the concept of component that I don't think here no one has to I don't need to explain again what a component is. But we have another concept that is the concept of driver. A driver is let's say the part that is communicating with the external world. So basically a driver is just a function that receives an observable as input. And potentially it may or may not return an output. So think, for instance, I don't know, when we want to manipulate the DOM. So when we want to manipulate the DOM, what we pass in Cycle is an observable with our data that will represent our virtual DOM, and then someone else is taking care to rendering the DOM. And then as output of this thing will be the objects that are created inside the DOM that I can interact with. And we will see that in a moment. Or another thing could be a driver that handles the WebSocket. WebSocket doesn't have to return anything. You just create a WebSocket, an infrastructure, and then you pass messages inside it. So in this case, we can have like a driver that is just an input driver. So you got an observable, and through the observable, I'm trying to interact with my entire application. So basically, the rule of thumb here is every time that you need to communicate with the external world, you try to create a driver. Currently, the Cycle community is pretty active on that, and there are already many drivers that you can use it. But interesting thing is that you are isolating that part in a driver. So it's pretty cool. Before we move to a real example, I want to talk about one thing that was I discovered thanks to Cycle.js, and personally I think it was a brilliant idea. That's why I want to share with you. So I would like to talk about an architecture that is fully reactive and was thought for that, and it's called Mode View Intent. Before that, I would like to see where we are now. So this is that looks, let's say, quite oldish, but it's not that oldish. We got a Mode View Presenter. Okay, so it's an architecture that is been around since 90s. Okay, so it's not pretty new, brand new, whatever. But a lot of frameworks nowadays are inspired by that. But you don't know that. The interesting part is the model view presenter is working this way. So we have a model where we store, let's say, our data for our application. Then we have a relation between the presenter and the view that is one-to-one. So every time that I create a view, I always create a presenter. And the presenter basically is retrieving enough data that my view needs in order to handle a representation on the screen. The view usually in this case is called passive view. So it's a view that is pretty dumb, and the only thing that it's doing is exposing some method in order to re-render everything for the on the client. The presenter is doing the behavioral part of your application, is retrieving just all the data that you need inside the presenter, and at the end is updating the view. The different concept from an MVC, for instance, is the controller usually is doing that for multiple views and is doing that for, let's say, multiple components. In this case, the relation is always one-to-one. If you think nowadays something like that, there are a couple of frameworks that are exactly doing this. But with model view intent, we are changing that. So another thing that I would like to mention here is that, as you can see from the arrows, is bidirectional. All the communication are bidirectional. Okay, so from the view, I listen for events. So the view is basically sending the events from the user interaction. The presenter is retrieving data from the model, is storing data from the model. So it's always this thing, bidirectional thing. But with model view intent, we drastically changed this way. So one of the things that I really loved about React, apart from the framework, is what Facebook came up with Flux. With Flux, they introduced the Flux pattern that is not just the name of the framework, but also the name of the pattern. And with Flux, what they leverage is the concept of monodirectional flow. So you always go in one direction. So if you know exactly which is the duty of a specific part of your application, you can pick it up and you can immediately spot bugs. You can immediately have new people that are joining inside your team that knows what they have to do, because it's very clear what you're doing. In MVI, we are doing exactly the same thing. So what we got here is basically, so let's start from where the state is. So the state usually in the MVI is inside the model. What the model is preparing is just how the data should be represented for the view. So the view is taking this information and is preparing what is called a virtual DOM. And usually there is a library that is, in this case, a side effect in this cycle that is doing the rendering. So in the example that we are going to see in a moment, I use Hyperscript in order to do that, because in the new version of Cycle, you're using basically SnapDOM, that is a very fast virtual DOM library that is embedded inside Cycle.js. So you can use whatever you want in Cycle. It's not mandatory using SnapDOM. You can also use React, but in this case, I got out of the box, fair enough. So as we said before, the driver is basically exposing just the DOM elements that I can interact with. And what is the intent? The intent is exactly what the name suggests. So it's just an object that is understanding what are the user interaction, retrieving the data that the user input inside the UI, and prepare them for the model. Then the model knows what to do. So pretty easy, no rocket science here. And as you can see in the flow, we don't have any more bidirectional communication, but we have a monodirectional one. Therefore, I can immediately understand where the things are. And that's something that is invaluable for me, in particular when you work with a large team and you work in large application. This is something that you can save a lot of time on bug fixing. So MVI in summary, a model shouldn't control any other module. We will see in a moment how the modules are going to communicate each other. The only shared part between the modules are observables. So when I started this talk, I described clearly what is the difference between interactive and reactive. So we are using totally the concept of reactivity. And what we are doing here is just using observable, therefore a third object, in order to communicate this information anywhere. Oh, sorry. That's a few things. The intent is a component that should understand what the user is doing and prepare the data for the model. And MVI allows you to work in a fractal architecture. That is what I described before. It's pretty cool. So let's see Cycle in action first, because I know too much talk sometimes, and you need to see some code. time to time. So what I'm going to show you is exactly this. So this one is a simple application. It's just so currently let me, I think that I'm online, so you should refresh at some point. So what we got here is basically all the trains that currently are running in London inside the tube. Nothing else. So I can pick a line here. This one is Piccadilly. I can go in Buckaroo line. And if I'm still connected, hopefully, probably not. Let me see if I'm still connected. Exactly not. Live demo. Oh, here we are. Yeah, no, I wasn't connected anymore. Okay, so now we should be there. In 3, 2, 1. Here we are. Okay, live again. So we got this reactive London tube data. So I move from Piccadilly to, I don't know, Northern Line. And in a moment when I receive the data, potentially it will change the view. Probably not. Nice. Here we are. Just slow internet connection. Okay, so we got the data, and I changed my data, and I got my view with everything. So it's pretty simple, okay? Nothing more, nothing less. So I just have this nice Dropbox to interact with, but it's more than enough. So let's start with the beginning. So usually when you have when you start, can you see over in the bottom? Maybe I can increase a little bit. Better? Thumbs up. Yeah, perfect. So what you usually have inside a Cycle.js application is this start of the application. It's pretty easy. So we got this. So inside run, that is the only method that is exposed inside Cycle. You don't have anything else, and that's why it's just 100 lines of code. You basically pass your application the drivers, and there is basically where the magic happens. So it's the glue that is created by the application in order to pass the observable through there. And here what I'm describing is basically, I got my application, I got my drivers, I create 2 drivers in this case. I got the DOM driver and the HTTP driver. So one will interact with the DOM, the other one will interact with an external call. Nothing fancy. So let's see with the app. Let's start from the bottom, because usually when you work in good functional programming, your code should be bottom up and not top down. But this is another kind of talk that we can do another time. So in this case, what I'm doing is basically pretty simple. Let me highlight for you. So here I'm doing the request. Obviously, every time that I got the request, I prepare. Yes, one thing that is important, this $sign. So this is called finish notation. Was created by the creator of Cycle.js, and now it's a standard in the reactive programming world. It's basically saying that this one is an observable. So it returns an observable. So you know immediately when you are writing with it that this is an observable, nothing else. What I'm doing is, so basically I'm doing a request, and then when I receive the response for the request, I'm preparing the data that will be rendered by the view, and then after that I pass to the view. Okay, let's see that. So let's see from networking. So I create my. Here we are. Let me close this. Perfect. Slightly better. So I create a request. In this case, I have, let's say, a few things. So as you can see here, what I'm using is access.periodic. So for instance, in this case, I'm creating an observable that has an interval time. It's like, imagine a set interval, okay? But it's wrapped inside an observable. And then I create another observable that what it's doing is just focusing on one thing, that is retrieving the data from the base, the URL for the tubes data. At the end of the day, what I'm doing here is using another operator that is combined in order to say, okay, I want an observable that is retrieving the data, and I want that observable will run every few seconds. And that's what I'm doing there. So the cool part of observables is that you can, let's say, interact with them in a very different way without writing fancy code. So if you think about that, you have to create your function inside the set interval that is doing that. So in this case, potentially, if I want to, let's say, decouple these two things, I can do that easily. It's the only glue that make that working together is exactly this. Just combine, so it's just one method. So it's pretty easy to deal with that. So when I receive the call, I process so when I receive the response, I process the response, and I start to retrieve the result from, and I wrap that inside an object that is called trains. Nothing crazy. Okay, so when I receive the response then, I prepare the state through the model that is at this level here, okay? So what I have here is basically I'm saying, okay, I have a response. I know what is also, if there is any, the action for the user. So you remember that I got the drop down potentially that I can use it. If nothing happened, the model should return what? The state of my stuff. So if I go here in the model, here we are. So first of all, I'm normalizing data. It's mainly because you know, the data that you receive from an endpoint like that are pretty generic, and therefore I need to create something that is easy to understand. Then what I say, okay, the first time, because the first time I set the Piccadilly line, I want to see some data. I don't want to see an empty application. Therefore, just the first time you run the default line, that for me the default line was the Piccadilly one. Otherwise, forget about it, and you basically retrieve the label of the line that is used in order to populate the top part of my application. And then I combine these two observable again, and I return a state. That is the state of the application. So at that stage, what I got is all the data that I display on the bottom of the application. I got all the name of the line that I picked, and I return all together in a unique observable to the view. So what the view does is just saying, okay, I retrieve that, and I call getBody. GetBody is a method that I create, template. And it's pretty easy, so also here from bottom to top. So I'm basically creating my UI. So here, basically, I pass the data, and I work in, let's say, in pure functions. So what I'm saying here is just I create the div, create an H1, and then I create my selector. Potentially, this one could retrieve from somewhere, but honestly, I didn't have an endpoint for that. Therefore, I did in this way. And then, slowly by slowly, I generate my data, creating each single element, passing function by function. Okay, so I know that if I want to test this, I can test in isolation this function without any problem, and everything will work perfectly. After that, let's assume that I have an interaction, so like the one that I showed you when I changed the Dropbox. So when I change the Dropbox, who is listening for that? It's listening the intent. So what the intent is doing is, because here at the bottom we said that we have the DOM, that is the view obviously is preparing the virtual tree that will be used by the DOM, and then I got these are the drivers that are continuously cycling inside my application. And the nice thing here is the fact that okay, the view is taking care about that, and this one is returning the DOM. In fact, the drivers that they are injecting inside my application, remember always the concept of cycle, the DOM driver is returning basically my, let's say, not the virtual DOM, but the real DOM. So what I'm doing here is basically say, okay, select the lines element and listen or react, that is better, to the events change. So every time that something is changing inside the dropdown, I'm trying to interact with that. And every time that this happens, I retrieve which is the thing, and I start the cycle. So I do the request, I pass this information to the model, I store that the model, I prepare the data, I pass this data to the view, and so on. So the thing is, literally, what I'm doing at this stage is creating all the necessary steps. And as you can see, everything is very atomic. So I can reuse this part wherever I want. And it's pretty, let's say, after a while, when you start to enter in the mindset of observable, it starts to become very easy to understand, because you see the composition that you're doing more than working with crazy things that you can see in some applications. So I'm running out of time. I'm conscious about that. But we have also we can discuss about that during the break potentially. So the last thing that I would like to say is I grabbed for you a few interesting information. So Cycle.js is the first one where you can find the framework. Awesome Cycle is a list on GitHub where you can find tons of useful resources to start with. Cycle.js Fundamentals is an old, let's say, video course on Egghead, but there are a lot of good insight on how Cycle was conceived at the beginning. Most importantly, I would suggest if you have 45 of your time, invest them in watching this video. It's a unidirectional data flow made by the creator of Cycle.js, and it's very, very interesting. It's going through a set of architectures and explain the benefit of working with a unidirectional data flow.